Welcome to Module 3, Planning the Research Lesson. Our team has picked rotations as the topic of its research lesson. They're using the rotations lesson from Everyday Mathematics as their departure point. Unlike Japan, which has an in-depth collection of existing lessons, this team does not have an extensive lesson library to choose from. That means this group has had to search out available lessons and even components of lessons with which to work. That's the case for many U.S. lesson study teams. Our team has brought an array of teaching materials to this session, from Escher videos and books to manipulatives like Cuisenaire rods. They're brainstorming, questioning, examining, wondering. And that's the whole point. What's out there? What will enhance this lesson? What will open up a student's mind, make him or her receptive, intrigued? Conversely, what may impede a student's learning, get in the way?
So if you look at page 60, they give you the cutout that's used on page 15. So if you wanted them to, instead of having the blocks at first, but to work with just a piece of paper that's cut out.
Those might actually be the tools that we lay out for kids to have choices with. You know, here's your Cuisenaire rods, here's your graph paper, here's, these cutout pieces. Play with what you want.
Well, I would assume that this is the same picture that's all on page 15, this one.
Right.
So if you cut out, not if you cut out the pieces individually, but if you cut out the whole shape. And then you can see, instead of worrying about the blocks falling apart.
so they can rotate it.
Yeah.
You can do it use
So you has
one
it at,
plane.
right.
It's
at
all
a
stuck
whole.
together, whereas
One
here the
plane,
blocks
yeah.
are going to fall apart.
I wonder if that would be maybe a follow-up to the blocks then. So that when we talked about the idea of rotating on a point, we could give them that cutout after they've explored it with the blocks to lay it over and say, okay, well, how does it turn? Where does it seem to rotate? At what point is that?
The team begins to build the actual lesson from the ground up. This time, they brainstorm and debate various introductions for the lesson, what one team member refers to as the hook.
Get them to understand, for example, is that a 90 degrees clockwise is the same as a 270 counterclockwise. In fact, back on this first sheet we had, I would think that question 3, most people are going to think of that as 90 degrees counterclockwise rather than 270 clockwise.
Is that something we could talk about in that lesson? Maybe introduce the idea of counterclockwise. I think that might be an important...
Especially since it's in their textual materials.
To some, such detail may seem like micromanaging. Think again. Such detail forms the very foundation of improving this particular lesson. How students react is the point. In fact, this team is building a detailed hypothesis of how these students will best learn rotation concepts. Like any good scientific hypothesis, theirs is built upon careful observation. They will test their hypothesis by teaching their lesson. They will evaluate its effectiveness by careful testing and observation. Their conclusions will be grounded in and based upon evidence. The end goal, of course, is that the research lesson will be demonstrably effective. To this end, the team not only builds the lesson piece by piece, but identifies the key points to evaluate. They document the actions that the teacher will take, the curriculum points that will be made, and the expected reactions of the students in a document called the Research Lesson Plan. They also craft an observation plan that documents what the observers of the research lesson will do. It's an easy way for team members to focus on the reactions of the student to the actions of the teacher. Together, these two documents provide a framework with which to work, to test a teaching hypothesis against the reality of students. That concludes Module 3. Next up, the classroom, or should we say the laboratory.